All right, in this lesson, we're going to combine what we've learned over the last two lessons about our reference angles, rotation angles, our cast rule, and our trig ratios. So the main key points are we're going to determine the exact ratios for a rotation angle given the point on a terminal arm. We've already taken a look at that a little bit. We're going to determine the ratios for a rotation angle given a different ratio for the angle. And one of the key points, we're going to solve equations in the form of sine of theta is equal to, cos of theta is equal to, or tan of theta is equal to, where the angle is going to be between 0 and 360 degrees. We know that we have a rotation angle is going to be the same as a reference angle in the first quadrant. It's going to be 180 minus the reference angle in quadrant 2, 180 plus the reference angle in quadrant 3, or 360 minus the reference angle in quadrant 4. We know our cast rule to show where our ratios are going to be positive or negative, where in quadrant 1 they're all, quadrant 2 is just sine, quadrant 3 it's just tan, quadrant 4 it's going to be cos. And we know that our ratios are opposite over hypotenuse, adjacent over hypotenuse, and our opposite over adjacent become y over r, x over r, and y over x, where r is represented by the radius going to that terminal point. So, for the first part, doing exact values of trig ratio given a point on a terminal arm. You are definitely going to be asked about this. So first thing, we take the point, we're going to draw the point on our axis. Point of P, which is -3 and 2. We're going to show our rotation angle. And we're going to show, going directly to that x-axis, our right angle that is going to occur here, where we know that my x value is -3, my y value is +2, and going from the origin to P, or R, is going to be calculated from r squared is equal to -3 squared plus 2 squared. If you use +3 and +2, it's not really going to make a difference because when I square it, it's going to make a positive anyways. R squared is going to equal 9 plus 4. R squared is equal to 13, which means that r is going to equal the square root of 13. Using this, write the three trig ratios for angle theta. Remember that theta in this case is going to be represented by, or represent, my reference angle, or theta r. So if that's the case, then sine of theta is going to be y over r, which in this case is 2 over the square root of 13. Or we should be in the habit of rationalizing because we already learned how to do that with radicals. 2 root 13 over 13, multiplying the top and the bottom by the radical of square root of 13. Cos of theta is going to be x over r, which is -3 over the square root of 13, or -3 root 13 over 13. Tan of theta is y over x, which is 2 over negative 3. Or you can just write the negative beside negative 2 over 3. Perfectly acceptable. For example 2, it says the point of negative 4, negative 2 lies on the terminal arm of the angle in standard position. Determine the exact value of sine of the angle. So I'm going to start by drawing what this looks like. There's my y, there's my x. I have my point of negative 4 and negative 2. Which means that my y value over here is negative 4. My x value up here is negative 2. There's my rotation angle. And I can solve my ratios based on my reference angle inside of there. I can state that x is equal to negative 4, y is equal to negative 2, and r is equal to the square root of x squared plus y squared, or the square root of negative 4 squared plus negative 2 squared, the square root of 20, and I'm going to simplify that down to 2 root 5. All it wants in this case is what sine of the angle is. So sine of theta, which is y over r, is negative 2 over 2 root 5. I can divide the top and the bottom by 2 to get negative 1 over root 5. And I'm going to rationalize by multiplying the top and the bottom by the square root of 5. Root 5 over 5. And there's my answer.